Let's take a look at access control policy for Zscaler Internet Access. So I'm going to start with firewall control policy. So I have a number of default rules in terms of Zscaler's one-click policy that I have configured, as well as Zscaler proxy IPs to be allowed through the firewall. And I've got a bunch of other rules here, and we'll take a look at this first one, which basically says allow traffic with full logging, and we say for a layer 4 service, so SSH, that's TCP port 22, and the application, so it's detected using DPI as being SSH, and destination IP is my jump host. We're going to allow access. So if we open up a terminal window, we SSH to jump host, will be permitted through, and we see that the source IP address is one of the Zscaler nodes, 165.225, within the Zscaler ranges. So we can come into analytics and we can take a look at our firewall insights, and we can look at the logs for the last couple of minutes. Click apply. Let's add a filter, destination IP, and if we exit from here, ping jump host, we can get that IP address out of there, and we can paste that as a destination IP and apply the filter. And so we see that transaction come through. We can see my client source IP, destination IP, and it was detected as SSH, and it matched that rule. We come back across to the policy. Of course, we can change this rule, and we can set it to block reset. Click save, and click activate. And if we come across here and SSH to it again, we'll get an immediate deny. So firewall rules apply immediately across the entire cloud infrastructure, and this is for all ports and protocols. SSH is an easy one to demonstrate. Let's take a look at DNS. So if we want to access something such as 0365, we'll open up an incognito window. We'll go to outlook.o365.com, we refresh this page briefly, what we'll see is that Microsoft uses CDN to access the O365. And so this is important to resolve to the closest node. And if we perform a dig on the client, this will pass through Zscaler internet access, and we receive an IP address which is local to the node. In this case, it's in the US. Now, if I perform the same dig towards something that my local DNS server, bypassing Zscaler internet access, I'll get a different IP address back. So it's important when your DNS isn't optimal, and this is often the case in guest hotspots, home networks, things like that, that you are doing the optimal DNS resolution to resolve the closest node, and you have the DNS security to go along with that to make sure that those DNS rules are properly filtered. Now, we can also do the same if the client is configured for DNS over HTTPS. So in this case, what I'll do is I'll so in this case, what I'll do is I'll resolve so it's also important that we consider DNS over HTTPS. Web browsers may be using that as well. So we need to be able to perform the DNS resolution and inspection for DNS over HTTPS as well. So in this case, what we'll do is we'll run a curl to synthesize a DNS over HTTPS request. We'll say accept application DNS JSON, and we'll resolve against Cloudflare's DNS 1.1.1.1 / DNS query, and we'll say we want name equals that res.cdn.office.net and type equals A, and we'll see what we get back. So in this case, again, we're doing the SSL inspection. Zscaler is performing the DNS resolution, and we get that answer back in the same way that we were as we're passing through the Zscaler node, and the Zscaler node is performing the DNS resolution. So we're performing inspection of DNS, we're performing DNS optimization, and of course, because we're doing the optimization and the inspection, we can filter that traffic. The DNS rules can prevent data exfiltration over DNS, as well as compromise and command and control through DNS, TXT records or whatever as well. Okay, so let's close this window down. And we'll come across and we'll take a look at policy for file type control. So file type control is a good object to prevent infection on machines, a hard block to prevent files being downloaded and then being passed to the sandbox to be inspected. So in this case, I've got a hard block for ISO images, easy to synthesize. We can say download Ubuntu ISO image. We can easily come across to the Ubuntu download page. We can click download, and of course what it'll do is it'll open up the download image, and then we get blocked. And Zscaler's looking at the file extension, the MIME type, as well as the magic bytes for the file to identify it as an ISO file, and we can then do that hard block of those files. Of course, if you allow files, then they'll go through the malware inspection and pass through all of our sandbox functionality as well. Taking a look at URL filtering, I've got some already configured rules here. So I'm going to try something like an 888.com, and it's going to get blocked. I have override configured, so if the user is configured as an override user, then they can bypass. And a good example of this is in schools, where you might have a teacher allowing young people to browse to websites or whatever. They get blocked for whatever reason, a legitimate block, and the teacher can then override on behalf of the individual. So they click here, it's going to go through the SAML authentication, it's doing a force auth n. Specific users are allowed to override that, so in this case it's myself. I'll click next. I'm forcibly challenged to enter my password. I will also be forcibly, because of my IDP configuration, asked to enter my multi-factor token. And at this point, that's authenticated, it's approved, comes back through the IDP flow, and then I can access that website. Other things we've got here, we've got just simple shopping websites, so I can go to Amazon. I get a soft block where I'm prompted as the end user whether I want to continue or not, and then I can click continue. And then I could also come in here and I could edit this page, and I say, well, actually, I don't want to do an allow, caution, or block. I want to isolate the traffic. Isolation enables me to prevent the user getting infected from the website if I don't trust the website, and functionality exists to do AI, machine-based learning, understanding whether content should be isolated or not. Or in this case a hard block and isolate the user. So if preventing infection, an air gap of the content getting to the user, they get the screen scrape pixels, and we also prevent data loss from the end user device up to those websites as well. So we click activate on this. All changes are active immediately. So at this point I go to Amazon and I'll be moved into isolation. We get a pop-up that says, hey, you've been isolated, and then I can interact with the website as if I'm directly accessing it, but of course all of this is within an isolated container, and I'm just getting the screen scraped pixels. So we were looking at O365. Let's talk about O365 tenant restrictions. So tenant restriction comes in a couple of different places. So the first place we need to do is configure our tenant profile. In this case, I say my tenant profile for O365 is called Welsh Geek. Cloud application is Microsoft Logon Services, and I define my tenant ID, my Azure AD Active Directory. I define my tenant, which is my Azure AD tenant ID, and my O365 tenants defined here as welshgeek.net. And so what's going to happen next is when I go to access O365, I'll have to log in. And as part of that login, that will be SSL inspected, and Zscaler will inject the right tenant restriction headers that O365 will be aware of and allow only those authenticated domains to go through. So it's predicated on two things. The first thing, we have SSL inspection. So I have the O365 one-click configured, but I need to specifically inspect the M365 logon pages. So there's a cloud application defined for inspection, and we're going to inspect this traffic. And then under our URL and Cloud App Control policy, we have a number of different services we're going to allow and deny based on policy. And then under the Microsoft Login Services, we're going to allow it, but make sure that that tenant profile we defined is applied. So if I go ahead and I'll open up a incognito browser here, and I'll go to my Outlook O365 tenant. It's going to redirect me to authenticate. Again, I'll enter my credentials. Because it's an isolated container, it's not going to do transparent single sign-on, so it'll prompt me for my credentials. I'll get prompted for multi-factor authentication again. And I'll log in, and now I can access my O365. So if we close this out and we come across to our tenant profiles, we'll go profiles, let's make a change here. Let's remove welshgeek.net. I don't want the user to access that domain, and we'll just say welshgeek.com to synthesize a different domain that is the only domain I should be allowed access to. If we redo that log on, let's go to Outlook again. Again, it's going to prompt me to authenticate. I'll enter my credentials. I'll still get prompted for multi-factor authentication. But actually, before multi-factor authentication has been triggered, it's applied that tenant restriction policy and says, hey, you're not allowed to sign into the welshgeek.net tenant because Zscaler has injected into those headers that the only tokens that should be issued by the Azure AD authentication process are for the welshgeek.com domain, and that's not what I'm accessing. So I've been flat refused access. Let's take a look at Zscaler private access application segmentation. So we have a number of application segments defined. My ADFS server, my CentOS server, my certificate servers, things like that. I'm going to specifically look at my Apache server. My Apache server here is defined as a web application. It's running on port 80 and 443. It's advertised for browser-based access. We've got inspection enabled, and it's also enabled for isolation. And so segmentation means that I can make a policy-based decision. This is only available to be accessed on port 80 and 443. If I wanted to allow SSH to it, I'll create a new segment for SSH, and I can write policy to allow or deny access on that. So the policy then comes in to make decisions on under what conditions and what criteria is the user allowed to access it. And so I have three very distinct rules here for my Apache server. The first rule says I need to have a SAML attribute that says it's managed, and that is managed attribute is coming from Azure AD. And an is managed device says it's Azure AD joined, it says Azure AD managed. I can write a compliance policy for it. And obviously in this case, I'm coming from a Mac, and therefore it is not, in this case, a managed device. So I'm saying it needs to be managed if I'm going to access it from the client connector or through a web browser when I'm using browser-based access. If that rule doesn't fire because those conditions aren't true, then it's going to come down to CBI, which is the isolation. And I say, okay, well, I'm going to allow the cloud browser to access it because we're going to make decisions on how to or when to send the user into cloud browser isolation. And then my final rule for Apache says, well, if it's neither of those two rules, I specifically want to block access. So what we're saying is the user needs to come from a managed device, either using Zscaler Client Connector or browser isolation, or they need to be coming through browser-based access from a managed device. So let's take a look at the isolation policy. The isolation policy says, well, if you're coming from a managed device, if this is managed device attribute is true, and you're using a web browser, then we'll just allow you direct access, in which case it's browser-based access. The second rule says if you're using the Apache application and you're coming from a web browser, then we're going to isolate you. And so these two top down say basically you have to be a managed device to access the application directly, otherwise we're going to isolate you. And that goes hand in hand with the access policy that says we're going to allow you to access it directly if you're a managed device, otherwise we're going to isolate you, otherwise we're going to block you. So let's take a look at how that looks in practice. So from my unmanaged device here, I'm running Zscaler Client Connector and Zscaler Private Access is running. And if I open apache.welshgeek.net, I'm going to get access denied. And that is aligned with this rule that says I'm going to block access because the user is neither coming from a managed device nor are they using cloud browser isolation. I haven't been sent into isolation yet. If I come across to a managed device here, let's open this up. We're running Zscaler Client Connector. We know it's a managed device because we can check those SAML attributes. We know it's a managed device because we can check those SAML attributes. We know it's a managed device because we can check those SAML attributes. So we can go SAML SP and we can do a logon process, and we can see here that is managed is true, is compliant is true, is known is true. So if we open the browser and we go to apache.welshgeek.net, we're able to access the website directly straight through Zscaler Private Access with Zscaler Client Connector. So if we come in here and let's open Zscaler, and we'll turn off Zscaler Private Access to synthesize the user being, let's say, off network on this device. We can close that down. If we open and we go to Apache, what we'll expect to happen now is we'll go through browser-based access. Again, those SAML attributes will be reviewed, and then we'll give access to the application. So we'll see the redirects happen. The user is redirected to log in via Azure AD. Now we've redirected to an HTTPS website, and this is the browser-based access to that application. So we're able to access the application. We'll see we've been redirected to HTTPS. We can look at these certificates, and it's coming directly from Zscaler. And if we come across now to my client machine here, let's open this. We'll turn off Zscaler Private Access here. We'll see now when we access apache.welshgeek.net what's going to happen is the user is sent into isolation. So now we went through that authentication flow. The authentication identified the device as unmanaged, and so it triggered that it was going through a browser, and therefore we should isolate the user. So 4 different experiences based on the device: denied access from an unmanaged device, isolated access from an unmanaged device, direct access with Zscaler client connector from the managed device, and direct browser-based access through the managed device, all through the Zscaler private access policy, and aligning that with our segmentation policy. Let's take a look at the diagnostics. We'll be able to see all of these in the diagnostics page. We can see here was the user hitting that CBI policy, and we see here that we're using cloud browser client type. This is the user accessing through the web browser. So this is the managed device. We can see the user metadata, and we'll see the SAML attributes here that says is managed is true. That's what the policy was applied on. And then we can also see the denies here for that unmanaged device, which triggered here. Oh no, that was a allowed access a bit further down. This was client connector. This is that managed device being allowed through. Again, we can see the SAML attributes is true. And then the block for the MAC going to it direct would have been prevented because of the client forwarding policy saying preventing access to that application segment as well.